Hello everyone, myself I am Shreya from Sri Venkateshwara College of Engineering.
Now I'm going to explain about full wave rectification.
So now firstly, what is full wave rectification? Full wave rectification rectifies the negative component of input voltage to a positive voltage, then it converts AC to DC during a diode bridge configuration. Example for full wave rectification is bridge rectifier. Full wave rectification rectifies the negative component to positive and it converts alternating current to direct current. Here in this diagram, you can see that this is the input waveform and this is the full wave rectification and this is the output. This is positive half cycle and this is negative half cycle, and here transformer T1 is present. This diode D1 and here diode D2 is present. Full wave rectification. The full wave rectifier circuit uses two diodes and its input voltage is supplied to the transformer T1 with a center tapered secondary winding. The circuit is essentially a combination of two half-cycle rectifier circuits, each separate from one of the transformer secondary. Here, in this figure, you can observe that transformer T1 is present and the diode is present at positive and D2 second diode is present at negative. Here load current is present. This is one half cycle, this is another half cycle. They both combine together and form full wave rectification. Now, operation of full wave rectification. When the transformer output voltage is positive at the top of diode D1 is positive and the center tape of transformer is connected to cathode D1 by RL. Here in previous diagram, we have seen that D1 is present at positive anode and transformer T1 is present. And here RL, the load resistance is present. D1 is forward biased from top of transformer secondary through D1, RL from top bottom and back to the transformer center tap. During this time, the polarity of voltage from bottom of half of transformer secondary causes D2 to be reverse biased. The current IL, load current flows from D1 to RL. Here RL means load resistance. And if the polarity of voltage is from bottom of transformer, then it is reverse biased. During the negative half cycle, the transformer output, the polarity of transformer secondary voltage causes T1 to be reverse biased and D2 to be forward biased. During this negative half cycle, transformer output polarity of transformer secondary, it causes to D1 and D1 is to be reverse biased and D2 is to be forward biased. If the IL flows from bottom of terminal of transformer secondary through the diode D2 through RL from top of bottom and back to transformer's center tape. Here, if IL flows from bottom of terminal to transformer secondary through the diode D2, IL flows from bottom of terminal to transformer secondary through the diode D2. The output waveform is the combination of two half cycles. There is a continuous series of positive half cycle of sinusoidal waveform. This is positive full wave rectification. The output waveform is the combination of two half cycles. So now this is one half cycle and this is another half cycle. They both combine together and form positive full wave rectification. Now this is a diagram of full wave rectification. This is the input waveform and this is the full wave rectifier and this is the output. Diode D1 and D2 are present and the here transformer T1 is present. IL, load current is present. It flows from positive to negative. And this is the output waveforms of full wave rectification. If the polarity of diode is reversed, the output waveform series sinusoidal negative half cycle, negative full wave rectification. If the diode D1 and D2 are reversed, then it is called negative full wave rectification. Here we can see that in top negative is present and at bottom positive is present. So this is negative full wave rectification. The center tape of transformer is grounded. Here the center tape transformer T1 is grounded as we can see in this figure. So now to obtain negative output, the circuit is reversed the diode polarity and the output looks like this. For normal diode, the output waveform looks like this, but if the diodes are reversed, then this is the output of negative full wave rectification. Now let us discuss about waveforms of full wave rectification. As earlier we have discussed, this is the input and these waves are output. Let us discuss about advantages of full wave rectification. Full wave rectification results in high average voltage than compared to half wave rectification. Half wave rectification gives less voltage and full wave rectification reduces ripple voltage in output form. It reduces the ripple voltage and it is mainly used in bridge rectifier. We can see the diagram of bridge rectifier. Now let us discuss about bridge rectifier. It is a type of full wave rectifier that uses 4 or more diodes in a bridge circuit configuration to convert AC current into DC. In bridge rectifier, it contains 4 diodes, namely D1, D2, D3, D4, and as usual, transformer is present and RL load resistance is present. And this is the input waveform, and this is the output waveform. The function of full wave rectification is to convert alternating current into direct current. Bridge rectifier is the circuit most frequently used for full wave rectification. It is most commonly used in full wave rectification. It consists of 4 diodes, as we earlier discussed. It consists of 4 diodes D1, D2, D3, and D4. And it is connected with the arrowhead symbols of pointing towards positive output terminal of the circuit. Diodes D1 and D2 are connected in series and D3, D4 are connected in series. Here D1 and D2 are connected in series and D3, D4 are connected in series. The positive output terminal is at cathode D1 and D3 and the negative output terminal is at anode D2 and D4. Here D1 and D3 are presented positive. This is cathode and D2 and D4 is presented negative anode. So this is cathode, this is anode. And now disadvantages of full wave rectifier. It is more complicable than half wave rectification. Half wave rectification is simple. Full wave rectification is more complicated. It requires more diodes, as we've seen that, and requires 2 or more diodes. And in bridge rectifier, we are using 4 or more. When small voltage is required to be rectified, the full wave rectifier circuit is not suitable. When small voltage is required to be rectified, then half wave rectification is suitable. And this full wave rectification is not suitable for small voltage. And conclusion. With a full wave rectifier, we get power in both positive and negative half wave for DC circuit. Full wave rectifier are most commonly used in rectification process. This is the most commonly used rectifier because they are efficiently compared to half wave rectifier. And finally, the process of converting an alternating current signal to direct current signal is known as full wave rectification. And this is about full wave rectification. Thank you.